What is lacking today is a temperature. In this datasheet, it is not given, and the response time. But we will talk about it for another webinar, because today we don't have enough time to do that. So the important thing is the datasheet is the dimension, the profile of use, the force, and the energy. So to begin our first calculation, we will use only two simple formula. The first formula is the mechanical formula, I mean the force of electromagnet, which is this one. The force is equal to square B times the section of the core and divided by the constant mu0. And the electrical power is given by this power equal voltage times current. So we will define our data sheet like this: a voltage of 1.2 volts, a power of 2.5 watts. Bmax, Bmax is the saturation magnetic field of our steel, of our plunger, and a holding stroke of 5 Newton. So this will give us the current and the first dimension of the plunger. So as we have a power of 2.5 watts and a voltage of 1.2 volts, we will have the dimension of the current, which is 2 ampere, and will give us the diameter of the wire, the diameter of the winding. So it's 2 ampere divided by the normal density of the current in the winding, which is 6, and it gives us the diameter of the wire. And the diameter or the radius of the plunger is given to us by this formula here. So I'm going to show you a design made with this information. But first of all, you have to know that QuickField won't do all for you. For instance, it's necessary to have this kind of information. I mean, the thermal coefficient of temperature, of heating. The coefficient, the thermal coefficient, depends on the geometry of the bobbin. So it's very important, as we will see further. And also the filling coefficient of winding, because when you are finished with the design, you have to come back to what you have found and to interpret the results. I mean, for instance, the filling coefficient of winding is only 0.5 and not 1. It means that, in fact, the space of the coil is not only full with copper. So what about the design? We'll take this one. So in our design, you can recognize the simple design was made in the beginning of this webinar, but this one is a little more complex because we have the coil here. We have designed the insulation of the wire. You can see here. Oops. The surrounding, the bobbin, the body, insulation, the plunger, of course, the resin, if we need to have some better insulation, and the support is, in fact, is the plastic part that support the coil or the winding. So what you can see here is the insulation part, the insulation design to check if the protection of the body is enough against electrical shock.